Okay, so I just want to look at your trig graphs and just some of the basis of the different graphs. So we're going to go 3 sine 2x minus pi on 2 plus 5. Okay, we're just going to look at what all these different numbers actually represent. So the 3, all right, that will give you your amplitude. And that actually, amplitude. And that actually just affects the y value. The 2 there, the 2 affects the period. So if you went, the period for a sine graph is 2 pi on n. So that's going to be 2 pi on 2, which is pi, which means it will repeat pi, every pi. So like if you, first of all, let's just look at those two things. If I just have my normal sine curve, so my normal sine curve will go like that, between 0 pi and 2 pi. But when you put a 3 in there, then it's going to oscillate between 3 and minus 3. When you go y equals 3 sine 2x, there's your normal sine function. It's going to go 3 and minus 3. And what will happen is, normally, see, it's 2 pi on 2 and 3 pi on 2. That the way that 2 will affect it, it will basically get these, and it'll you divide like the opposite sign. So you divide all the x's by 2. So this one here will become pi on 4. The pi will become pi on 2. The 3 pi on 2 will become 3 pi on 2 times 2, which is 3 pi on 4. And the 2 pi will become 2 pi on 2, which is pi. Okay, and what you might notice there is that it is repeating. You can see it repeats after pi, and that there is 1 period. Okay, so that's basically what that 2 there will do. The plus 5 there is pretty simple. The plus 5 will move it up 5. So whatever graph you've got, if you're up to this like this, and then you added 5, it's just going to shift it up 1, 2, 3, 4, 5. And then it's still going to go amplitude up. So I'm just getting myself a little bit more space there, because that really was hardly any. Okay, so you go 1, 2, 3, 4, 5, and then you go 1, 2, 3, so that's 8, and if that's 5, go 3 down, so that's going to be 2. So it's your normal sine graph, so it's going to be like that. That's how it's going to be oscillating. It's going to be pi on 2, pi on 4, 3 pi on 4, and pi, because that's it's repeating, but you notice it has gone up 5. Okay, now I just want to talk about when you're adding that number here. So that's when you go, say, plus alpha. That would shift it left, so it's the opposite sign alpha. It's whatever it takes to like solve this equation. See, so it'll be x equals minus alpha. Now, if you had a negative there, that would be shift to the right alpha. Okay, so just once you put something in front of here like this, and we had, that's the 2 pi on 2, we call this shift, we call it the phase. So the phase is how much it shifts left or right. Once you chuck a number in front of here like this, once you have a number in front of there, you need to actually take the 2 out, and that would be pi on 2 times 2. So it's going to be sine of 2x minus pi on 4. The actual phase, or the actual shift, will equal pi on 4. Okay, so if you were sketching it, you could shift right. You could dilate first. So if you're going to do it in this order, how we've got this one here, you could do this in 2 ways. If you're going to sketch it like that, you dilate first. So So you dilate first, and then you shift to the right pi on 4. So it's as if you were solving this equation for 0, and that's one way of checking, because when y equals 0, sine of the function will equal 0. So when you solve that, you divide by 2. So that's the first thing. So you're dilating, and then you're adding your pi on 4. Okay, so the other way of looking at this is if you kept it like this, it'll still have an overall phase. Like if you want to get the phase can only be done by factorising out the 2. So if you have this here, the first thing that you could do is you could shift to the right pi on 2, and then you dilate by a scale factor of 2. So you've got your normal curve here, your sine curve. I'll just do that. So that's 2 pi on 2, 3 pi on 2. So we're going to do the shift first, and either of these ways will work, but I think it's sometimes easier to shift pi on 2 than pi on 4. Okay, so if you shift to the right pi on 2, so that would be there. This one here goes to there, the pi goes to there. This one goes to here, and then it'll be back up there. So you've kind of got the basis of what's going on here. This is your basic pattern of your curve. So this one here, this is just sine x minus pi on 2. Now what you have to do is you're actually doing like f of 2x. So you're now dilating the x component by 2. So you're going to go through and divide by 2. So you divide everything by 2. So your final graph will end up being, we know it's going to start there and go like that. That will be pi on 4, because it was pi on 2 divided by 2. Pi divided by 2 is pi on 2. This one here would be 3 pi on 4, because it's 3 pi on 2 divided by 2. And 2 pi divided by 2 is pi. So that's your x and your y. So two ways when you've got this. You could, first of all, factorise the a out. And in a trig function, that would be your phase shift. And it shifts it left or right, depending on its sign. And it's the opposite. So if it's minus b on a, it has to go right b on a. Okay? And when you're actually sketching this and you're using this technique, you would dilate first and then you shift. And the thing is, it's the same as like if you were doing the reverse operations on solving an equation like that. So you'd first divide by a, and then you add b on a. Alright, now when you're actually sketching, I feel the better way, or the way I find easier, especially when you're doing trig functions, is to shift by b and then dilate b on a. So when you're actually looking at trig functions, the phase shift for the trig function would be b on a, not just the b, because it has to be the dilated shift. So for example, this one here, you've got your cos curve, which looks like that. So that's pi on 2 pi, 3 pi on 2, and 2 pi. The plus pi on 2, that would be to the left pi on 2. So it goes from here to here, here to here. This one here will go to here. This one will go to here. So you can get the gist of it. Alright, that should be through 2 pi. So there's your thing. So I've shifted it pi on 2, and now I'm going to dilate by a scale factor of 1/3. Okay, so if I get the pi on 2 and I times by 1/3, it goes pi on 6. Get the pi times 1/3 is pi on 3. 3 pi on 2 times 1/3, pi on 2. and 2 pi times 1/3, which would be 2 pi on 3. So here's the graph. You got 0, it'll be pi on 6, pi on 3. Then the next one was pi on 2 and 2 pi on 3. So it starts here and it will go, sorry, it doesn't. It goes down first, doesn't it? Down, up, and then back, down again. And see, it matches my period. My period's 2 pi n on n, and my n is actually 3. So it's 2 pi on 3. And notice that, that matches that there, the period. And that 3 comes from the number in front of the x.